Normally, the automatic feeders feed the tape by steps of 4 millimeters. We have seen in another video that it is possible to create simple actuators to allow the feeder to feed the tape by steps of multiples of 4 millimeters. So the steps become 8, 12, 16 millimeters, and so on. But for some tapes, 4 millimeter steps is too much. For example, the resistors 0402 have 2 millimeters pitch, so a step of 2 millimeters is required. Well, the previous method doesn't work for a fraction of steps. For this kind of problem, we need a more complex solution. We need to create a head actuator and a push-pull feeder. So the step will be 4 millimeters, but the head will move forward 2 millimeters to take the first component, and back to the original location spot to take the second component. The feed of the tape will still be 4 millimeters, but we will have two pickup locations 2 millimeters apart. Let's see how it is done. We will also see how to fix problems that may arise, like for example the resistors jumping on the tape or a non-precise placement of the components on the board. We create a head actuator. Pay attention, there are also no head actuators. Reference actuator. The actuator will be specific to the feeder slot address. So we need to create as many actuators as the slots we intend to use with our 0402 resistor tapes. We give to the actuator the name related to the address. In my case, the address is 178. Then we change the driver to CH341A, the one that controls the communication rail for the feeders. Something to say about machine coordination. I didn't have any errors, but one of my customers had this error after a few placements. We fixed the error by changing the machine coordination to this setting. Depending on the release of openPNP that you are using, the interface may be different. In the last releases is something like this. We click on Apply. Now we need to create a G-code for this actuator. Obviously, we select the driver CH341A. We select the G-code tab. We select our actuator and actuate Boolean command. We write the code associated with the address of our feeder's slot. And as usual, we click on Apply. It is the moment to create a push-pull feeder. First of all, we choose a pick location for the feeder. Here I made a mistake. Choosing this location leaves 4 resistors exposed to vibrations, increasing the risk of jump and loss of the components. Later I have chosen this location as a pick location. However, we center the location with the viewfinder and we acquire its position. We should set AZ distance of the pick location. If we click on Auto Setup now, a pop-up message will inform us that AZ distance is required in order to auto set up the visual system. So we set the Z value. But before doing this, we calibrate the tip 503. Here is where you can find the tips associated with the components. We go for the tip calibration. We move the tip over the pick location and we lower the tip till it is 1 or 2/10 of a millimeter from the tape. We don't want the tip to touch the tape to prevent the resistors from jumping. We acquire the position. We click on Apply. We put the camera on the pick location and we click on Auto Setup. Here we can see only one pick location because we didn't set the part pitch to the correct value. After we set the part pitch to 2 millimeters, this is the result. However, after you click on Auto Setup, you will have the values for the 2 holes filled in. Let's go on with the other settings. Part pitch, 2 millimeters. Rotation, 90. Precision, 0.05 millimeters. Deselect OCR action and on job start. In the push-pull tab, select our feeder actuator. Click on Apply and enable the feeder. We load a job and we select some pads to test our feeder. Note, the pads on the wheel with ID designator have a registration point not in the center, but in one of the corners. These pads are a little bigger than the pads in the vertical column. However, I selected 2 of these pads in the wheel, and I changed their defined location by acquiring their central position. Then I assigned to this pads the part R402. We need to write the height of the part, 0.3 millimeters. And we need to associate a nozzle tip to the package. Now I can perform a fiducial check of the board. Started the job. This is the message I can read when the bottom vision doesn't see a component. And the reason is because the component jumped from the tape and the tip was not able to pick it up. So I changed the pick location to the component closer to the beginning of the peeled transparent film, and the result was this. I still had some problems with the resistor jumping, which I fixed with the plastic support. I inserted the small support after pulling up the metal band in order to not give too much pressure on the tape. This would have forced the motor. Once this problem was solved, I had to face another problem. The imprecise positioning. So I tested the alignment of the component, suspecting an error in the bottom vision. But after performing a feed-in pick on the part and testing the alignment, I was sure that the bottom vision was working correctly. I suspected the problem was an uncalibrated N1, N2 offset. I did the offset calibration with the tip 504 and not 503. So I performed a precise offset calibration with the tip 503. Link to the video of the precise calibration procedure in the description. And the problem was fixed. So I selected 4 pads for my job. Performed again a fiducial check of the board. Started the job, and the placements didn't have problems anymore.